Okay, this video, we're going to go over the math team tryout from Meet 2. We'll go in increasing order of difficulty. So we'll start at event 3. Now this is Algebra 1. This is probably the easiest event of the entire year. Okay, so the first thing you do when you see the tryout, when you see these decimals, change them to fractions right away. So we got 3/8 k squared y minus 1 plus 1/4 y plus 1 is equal to 1/8 k 5y plus 1. First thing, multiply both sides by the least common denominator to get rid of the fraction. So 8, this becomes 2, and that cancels out. So what you got to do is multiply out everything. 3k squared y minus 3k squared plus 2y plus 2 is equal to 5ky plus k. Now we are trying to solve for y. Now these are just linear equations. You can't get easier than this. So put all the y's on one side of the equation. Let's put them all on the left. Put everything else on the other side. So these terms put on the right side. Factor out the y. Divide. And that's your answer, except you gotta simplify your answer. So, is this factorable? Yes, it usually is. So 3k and k, 2 and 1, what is that, plus, minus? And this one is 3k and k, 2 and 1, minus, minus. Something's wrong here. Did I bring something over? Wait, let me concentrate. 3k squared plus k minus 2. I did that one correctly. 3k squared minus 5k plus 2. 3k and k. 1 and 2. Oh, I did it correctly. What? Anyway, these cancel out. So therefore your final answer, k plus 1 over k minus 1. Boom. That's the easiest event. Just do that every single time. It doesn't matter what variables you have in there. Whatever variable you're solving for, put it on one side, everything else goes on the other. Okay, the next easiest event would be, well, it's easy if you know what's going on, and this is event 5. Now, I think I need the whole board for this. Now, you need to watch the video that was sent out for you guys who never took pre-calculus before, because in pre-calculus we actually learn logic, so we go through it, but you guys didn't, so you need to watch that video. So that's pretty much the lesson I give to my pre-cal honor students. Okay, which of the following statements are logically equivalent to A or not B? Okay, so in the first line, okay, so here's A, not A or B. Now, I can distribute this negation sign, but, so you can kind of think of it like a negative sign. It works like a negative sign. But this or changes to and. Is that the same thing as that? No. Okay, B, not A and B. So again, I can distribute the negation sign, but I got to change the and to or. So this becomes A or not B. That's the same thing. So B is one of the correct answers there. Now, how do you convert an or statement to a conditional statement? Well, if you watch the video, you know. Negate the first, leave the second one alone. And whenever you have a conditional statement, that's going to be logically equivalent to its contrapositive. The contrapositive of this is B implies A. So right there, you have two more logically equivalent statements, and that would be D and F. Right there. So B, D, and F we know are true. Now, why is it not C and E? Well, C is A implies B. Well, whenever you have a conditional statement, like this, or like this, it's only logically equivalent to its contrapositive. So like this, so if you have this statement, this statement is the converse of that. That is not logically equivalent. And so that's why these things you need to know from watching the video or looking at the notes. There's a whole bunch of notes on the website now. You guys need to look at that, because this event could be difficult if you don't know these things. Okay, now, to do the lower level, G, H, I, and J, you have to know how to compute, how to do truth tables. Okay, I'm going to do just one of these. I want to look at one which has like a lot of the things. Okay, what the heck, let's just do G. Okay, not A if and only if B implies A. Now, this statement here, A or not B, let's make a truth table for that. A or not B. So, our two statements are A and B. Normally in logic we have P and Q, but it doesn't matter what letter we have, okay? So, the customary way of doing it is the first letter would be true, true, false, false, and then the second is true, false, true, false. That's how you get all four possibilities. Now, we already know A is true, true, false, false, and not B is like the opposite of B. So if B is true, 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 false, then not B is going to be false, true, true. Now, the OR statement. The OR statement is true when at least one of the two components is true. So you just look at this. Is at least one of them true? Yes. Is at least one of them true? Is at least one of them true? No. Is at least one of them true? Yes. So this is the truth table for that statement right there. So that's why you have to know all the rules. So when you look at the video, the rules you gotta know how to do OR, see P or Q. You gotta know how to do AND. You gotta know how to do conditional, and then you gotta know how to do biconditional. And then of course you gotta know how to do negation. These are the 5 main ones. Look at the notes. Watch the video. So, right here, if A is true, true, false, false, then not A gonna be false, false, true, true. We know B is true, false, so fill that in, true, false, false. Now, biconditional, if and only if. Okay? That is true when the two components are the same. So, you look at this. Are they the same? No. These two, are they the same? Yes. Are they the same? Yes. Are they the same? No. So, this column represents this. Now we got to put that together with A. Well, we already know A is true, true, false, false. Now, the conditional statement, how does that work? The conditional statement, the only time it's false is when the first one is true and the second one is false. That's the only time it's false. All other cases it's true. So, look at this. We have a conditional statement. So this implies this. A false implies a true. That's true because the only time it's false is when the first one is true and the second one is false. So, a true implies a true. That's true. True implies false right there. See, that's the only time that it's false. And then false implies false is true. So this statement there represents this statement. And if this truth table is exactly the same as that truth table, we say that the statements are logically equivalent. So that's why G is one of the correct answers. So what you would have to do in this problem is you need to make a truth table for H, I, and J as well. And as it turns out, they're all logically equivalent to this because the truth table comes out exactly the same. So, if you're in this event, you have to be very good and efficient at making truth tables. And other things as well that I didn't test you on this tryout. So you need to watch that video. Because if you don't, you're going to be in big trouble and then I'm going to have to hunt you down. Okay, event 2, geometry. Okay, now before we do geometry, now for those of you who were on the math team before, you had access to the website. If you went to event 2, had all the notes there for the similar triangles. So you need to look at those notes. I'm going to just go over the ones that are going to be pertinent for this problem. I need some more room. So, if you have a triangle and you bisect this angle up here, and this is A, B, C, and D, then A over B is equal to C over D. This is called the angle bisector theorem. And there's also a secret theorem that goes with that. I'm not going to say it on video because we don't want other people to watch this video. It's on the notes. But what the heck is going to come up in this problem anyway? So here, let's call that x. So x squared is equal to AC minus BD. That's like a result of the angle bisector theorem, but we just memorize it. We want to use it, yeah? So, in this problem, you got a right triangle. This angle is trisected, so this equals this equals this. This is 2. What else do we know? This is 8/3, going all the way to here. Do we know anything else? Find AC, so why don't we call this x? Always try to label the thing you're trying to find x. Okay, well, if you have a right triangle right here, you can use the Pythagorean theorem to figure out that side right there, right? So, why don't we call that, let's call it box. So, box squared is equal to 2 squared, we can do that, 4, plus 8/3 squared, 64 ninths. So that's equal to 36 ninths, so that's 100 ninths. So therefore the box is equal to 10/3. So this is 10/3. So if we label this y, this would be 8/3 minus y. We can apply the angle bisector theorem. So since this angle is bisected, this over this equals that over that. 2 over y is equal to 10/3 all over 8/3 minus y. See, you write that down on your paper, you can get a point. You got to write down things that are going to be useful. So if I cross multiply, you get 16/3 minus 2y is equal to 10/3 y. 16/3 is equal to 16/3. If I add 2y to that, what is that? 16/3? Y? Y equal 1? Okay, well, that means this is 1, and this is 5/3. Right there. Okay, now we got to try to find x. Well, see, the thing is, x is like part of this triangle right here, right? So we could use the angle. See, since we know this, we know this squared is equal to that times that minus that times that. Well, all we got to do is figure out the other ones. Well, look, right here. There's a right triangle right here. This is 1 and that's 2. Using the Pythagorean theorem, wouldn't this be the square root of 5? So if I could just figure out what this is right there, I'm in business. Do we know what that is? Yeah, we could just use the angle bisector theorem, right? What do we want to call that? Z then. So this, since this angle is bisected, this over that equals that over that. Okay, so let's write that down. Root 5 over 8/3 minus, oh, well, we know what that is. It's 5/3 now. So this over this equals x over z. But we got two variables, so we need another equation, and that comes from the second part of the angle bisector theorem. So if you look at this triangle right here, this squared, let's write that down, 10/3 squared is equal to this times this, root 5x, minus this times that, 5/3 z. And then now you got two equations, two variables, and then you can just solve it. I think I can leave the solving to you, can I? Or you know what? I don't trust you. 100 over 9 is equal to root 5x minus 5/3 z. So what shall we do? Cross multiply this equation. 5/3 x equal root 5z. So since we're solving for x, probably solve for z, yeah? So z is equal to, if you divide by root 5 over 3x. Did I do that correctly? Of course, I'm the teacher. Plug it into the other equation. 100 over 9 is equal to root 5x minus 5/3 z, but z is root 5 over 3x. So if you make a least common denominator, which is 9, you get 9 root 5x minus 5 root 5x. Let's just come over here. So that's 100 over 9 is equal to 4 root 5x over 9. Multiply both sides by 9. 4 goes into 125, so x is equal to 25 divided by root 5, which is 5 root 5. You cannot have any radicals in the denominator. That was a good problem. So if you don't know these theorems, no can do. And another thing, you guys better watch the video on, or not the video, but look at the notes. When you have a right triangle and you drop this altitude to the opposite side here, so there's a right angle there and a right angle there. There's all kinds of things, A, B, C, and then D, E, F. You have to know these things. Like, for example, I'll just give you one of them. For example, A squared is equal to E times C. You need to just look at it and know. So you really need to look at these notes, people. Okay, the next easiest event is event 1. Now, even if you're in JV, you guys should learn how to do event 1 because this comes up in chemistry, physics. So the first thing you got to do is you got to read and then you got to write the equation. A is jointly proportional to B and the cube of C and inversely proportional to the square root of D. So that's the first thing you got to do is write down that equation. So what is this K? That's called the constant of proportionality. Anytime you have something is proportional to something else, you have to have this constant of proportionality there. Now, if B is decreased by 62.5%, C is increased by 33 and 1/3%, and D is increased by 96%, by what percent is A decreased? So this is how I do the problem. I call this A1, that's what you start with. And then I look at A2, okay? So, what's happened? B gets increased, no, it says B is decreased by 62.5%, which is 5/8. So if B gets decreased by 5/8, what's left? 3/8 B. See how I work with fractions? Yeah, because there's no calculator here. C is increased by 33 and 1/3%, which is 1/3. So C goes from 1C to 4/3 C. So 4/3 C, but then that gets cubed. Now what about D? D is increased by 96%. So it's going to go from what? It's going to go from 1D to 1.96D. Now, if you change that to a fraction, what is that? That's 196 over 100, which can be reduced to divide by 4. No, we can divide by, what, 4 goes into that what am I saying? 49. Oh, that's perfect. 49 over 25D then. See how that's good, because you can square root it. So, this becomes K 3/8 B cubed at 64 over 27C cubed, and then this becomes 7/5 radical D. So compared to the original one, which is A1, what is that? Isn't that 3/8 times 64 over 27 over 7/5 times the original? So that's how much, after all these changes occur, that's what you're going to be left with. So let's simplify that. So that's A1 times 3/8 times 64 27 times 5/7. I bet you a lot of things cancel out. 8 goes into 64 8 times. 3 goes into 27 9 times. That's it, yeah? So this is the original times 40 over 63. So after all these changes occur, you're left with 40 over 63 times the original amount. So that means it decreased, right? How much did it decrease by? 23 over 63. So 23 over 63, we got to figure out what percent that is. And you guys know how to change a fraction to a percent, yeah? You guys got to actually you have no calculator now. So 63 goes into 23. Do I really have to do this? Okay, 63 goes into 230. Looks like 3 times 918. Get rid of it. So that's 1, but I had to borrow. So 410. 63 goes into 410. Looks like 6 times, that's what it looks like. 8 carry 1, so 2 borrow 320. 63 goes into 320, that looks like 5 times, huh? 5 carry 1, 3, 1, and then you get 5 remainder, but 63 can't go into that, so it's going to be 0. So, if you move the decimal place 2 to the right, you get 36.5%. So after all these changes occur, A decreases by 36.5%. See all the computations you got to do? That's fun. Okay, the next toughest problem was number 6. Hey, even if you're in JV, I think you can learn something from this. Okay, number 6. Solve for x. X cubed plus 2 is greater than 3x. And now in this event, you gotta know the difference between and or. And means intersection, or means union. Absolute value of x plus 3 is less than 5x plus 2. Okay, so this one doesn't have absolute values, so it should be easy. Make one side 0. Okay, and then you need to factor this. So since it's cubed, use synthetic division, or if you want to factor by grouping. I don't care what you do, but you gotta factor it. Okay, so if you factor it correctly, I'm just going to tell you to save time. It comes out to this. Anyway, I have this one memorized because I use it so often. Okay? And then, of course, you make a number line, right? This event, you're making number lines galore. So, -2 and 1, neither of them are part of the solution. And then, think of a number bigger than 1, plug it in 2. Positive times positive is positive. It's going to stay the same because even power, and then it's going to switch because of the odd power. Greater than 0, so we shade in the plus signs there. Don't forget, it doesn't include 1. Now, that's kind of pretty important there. Okay, so that's the solution for the first one. Now, the second one, now, when you have the absolute value of something is less than something, then you put that in the middle. And then what did you put here and here? Negative gorilla and gorilla, like that. Now, when you have an inequality like this, what does that mean? It means this is less than this, and this is less than this. So, negative 5x minus 2 is less than x plus 3, and x plus 3 is less than 5x plus 2. Everything depends on the setup of the problem. If this was a greater than sign there, then this would become an or inequality. It's in the notes. Okay, solve each one. So, negative 6x is less than 5. X is greater than negative 5, 6. And then over here, negative 4x is less than negative 1. X is greater than 1, 4. Now you got to take the intersection of the two. Now, if you have problems, then I would suggest do this. How do you graph x is greater than negative 5, 6? Banana. How do you graph x is greater than 1, 4? Baguga. Where do they overlap? Look at that. X is greater than 1, 4, right there. And then, and means you have to take the intersection of this with this. So I would suggest stack the number line. So here's 1, 4. Just look at that. Where do they overlap? And means where they overlap, yeah? So that would be between 1/4 and 1, and then from 1 to infinity and beyond. Bam! That's your answer. So you really got to know the difference between and or. Otherwise you're going to be sunk. And finally, the trig. Well, for those of you who already took Algebra 2 honors or pre-calculus, then you should be able to do this. Okay, 4. Solve this equation between 0 and 2 pi. Notice that this angle is double that angle. Now, some of you tried to do a u substitution, u equal 3x. That's fine. Why not just go sine 2 times 3x is equal to cosine 3x? I mean, that's the same thing. So you got to use double angle here. The identity for sine of 2 theta is 2 sine theta cosine theta equals cosine 3x. Now, I was looking at some of your tryout problems. Some of you are canceling out cosine 3x. You just lost 6 solutions by doing that. You do not ever cancel a variable from both sides of an equation. You lose solutions that way. You make one side 0, and then you factor it out. If something times something equals 0, that means either this one is 0, or this one is 0. So sine 3x equals 1/2. And what a surprise, it's all numbers we're supposed to know. So cosine of what angle is equal to 0? Pi over 2, 3 pi over 2. Except, since the variable is 3x, you got to go 3 times around. So you have to add 2 pi to each of these. So that would be 5 pi over 2, 7 pi over 2. And then you got to go another time around. So that would be 9 pi over 2 and 11 pi over 2. Now what about this one? Sine of what angle is 1/2? Well, that would be pi over 6 and 5 pi over 6. Except again, the variable is 3x, so you got to go 3 times around. So add 2 pi to each of these. 13 pi over 6, 17 pi over 6, and then go one more time. 25 pi over 6 and 29 pi over 6. So to get your answers, all you have to do is divide all of these by 3. So yes, there are 12 answers for that problem. All right, let's learn. Yeah.